Good day. This is another type of reaction you are responsible for. Nucleophilic substitution reaction. So it means we're taking a chemical, and that chemical wants to bond with the nucleus of another atom, and that's going to be a carbon atom. So there's all kinds of overkill. You can read through it, but we're going to try to boil it down here for you. If you look at this R represents a carbon chain that says bromines on it. We're adding a base. KOH would be an example of a base. And essentially what we're doing is we're swapping the OH for the Br. In other words, the OH wants to attach that carbon atom, and the bromine becomes a bromide and attaches to the potassium. But the OH wants to be with carbon more than the bromine. So now the OH is part of the carbon chain, so we've made an alcohol, and the potassium and the bromide have gone and traveled away, and we've made a salt there. So it talks about happening in saturated carbon compounds, so that means typically alkanes. It says less often an aromatic, so that means benzene. And it says it can happen in unsaturated, but it's rare. So here we start with 1-chloropropane, chlorine on the end. So we know that Cl is going to get together with the Na, and we know the OH is going to attach that carbon. That's how we end up with 1-propanol. So use this as a guide when you get to, you won't run this very often on worksheets, and maybe you'll get 1 or 2 questions like this in a test. But hopefully you can see it's a fairly straightforward pattern for nucleophilic substitution.